Well, hello everyone. Lee Reagan here, coming from wonderful sunny Mirion, Connecticut. I'm going to make a presentation to you guys today on the Series 6 LB, and we will also have a live demonstration of the product. So thank you, Hope. I appreciate the introduction, and we'll just hop right into it if that's okay. So first off, let's get some things out of the way. The question that a lot of people ask is, well, what does the term Series 6 and Series 6 LB, what does that mean? Series 6 implies that there have been previous generations of this type of system, and that's true. So if you go back to the 1970s, we had a product called the LB5100, as we have a little picture of the front panel of the unit up there. And over the years, we have improved and added to the series number, and series 1, 2, 3, ZW, and then in 1994 we did the series 4, and then we started in the series 5 a couple of years after that. The series 5 today, we have the series 5 XLB and the series 5 LB5500. So oh, and the term LB is for low background, which is another term for alpha beta counting, or for gas flow proportional counter, GFPC. So LB. So we'll just jump right into it, and we'll start talking about the Series 6 LB. So first off, what's so great about the Series 6 LB? Well, the first couple of features that I'm talking about here are very similar to what's happening with the Series 5 XLB. So, okay, so it's got a 2 1/4 inch gas flow proportional detector. It has an automatic sample changer and has 50 or 100 sample capacity. It has integrated and bolted lead. Okay, so from there, let's talk about improvements. So not only is the lead integrated and bolted, it's also coated, as you're going to see when we pull the system apart in a few minutes. And in addition to it having 50 or 100 sample capacity, we also have easily removable sample masks, and this will allow you to load samples on the table or offline somewhere, as you'll see. We've also added a gasless guard detector to the unit. So the Series 5 XLB had a guard detector, but it was a gas flow guard. This is the first of our units, first of our gas flow units anyway, to have a gasless guard. We have built-in standard gas conservation. A nice selling feature of this system is that it uses the same software as our previous generations of systems. The current people who have Series 5 XLB or LB4200 or some of our legacy systems can use the same software package to control those systems as control the Series 6 LB. A really nice feature that we've added in the Series 6 that I'll demonstrate is counting by software or Express. So anybody who's used Apex Alpha Beta or Eclipse or any of those previous generations of software packages knows that you are always starting the count through the software interface. This software and this system, Series 6, allows you to actually do your routine counts through the front panel. Now, you're still counting through Apex Alpha Beta, but you're not having to go through the actions of opening the software, starting the software, and all that. So I'll demonstrate that and show you how easy it is to do those things. And of course, this is the first generation of the Series 6. We have planned upgrades that we're going to be doing. In fact, I'm going to be asking for some feedback a little later in this presentation from you guys on how we should do something. So be on the lookout for that. I'll mention it as we get there. So the first thing that I wanted to show you is that the system, we came up with the concept of the system on the slide. Now, the system on the slide allows you to access the detector area very easily, whereas in the past, on a Series 5 XLB, for example, what you would have to do is you'd have to come in, you would have to take the rear cover off, which is about 6 screws. You would have to pull the cover off. You would then come in and take out 4 thumb screws, pull out 2 lead bricks that weigh 20-ish pounds each, and then once you're in there, you have to remove 2 screws to pull the detector assembly out, and then once that detector assembly is out, it's still connected via a preamp cable, but you have to find a place to place that to be able to do any work on it that you needed to do, or to get out into the chamber to clean it out or whatever, because this type of unit, being that it counts filter samples and smear samples, sometimes those samples do get lost in the system itself. But this system is, as you can see, there's from my colleague here who's pulling the system open. It's very, very easy to get in. There's a latch on the bottom. You open the latch, and then the entire unit comes out. And I have a unit here that I'm going to be showing you guys in a few minutes. So we can access the detector area with absolutely no lifting of lead bricks. So there's and this is what the unit looks like when it's pulled open. So you have the sample detector. Again, it's the same sample detector that we've been using for many years now. We've just improved processes, improved materials, and continue to improve that through continuous improvement. This is showing a picture of the Guard Detector that we'll talk about in another slide in a minute. We have the slide shielding, and notice the red there, that slide shielding, that is a coated lead, so that you're not going to have any exposed lead in your laboratory. Where the Series 5 XLB, it has a raw lead shield. Of course, you have covers on it, but if you take those covers off, of course, you're going to have the potential lead exposure. We have what's called a front-end controller, which is the preamplifier, the high voltage, the gas control, and then we have the Series 6 controller, which is in the front, and that's where the LCD panel is. So here is a picture of the lead shield. In shape and design, it's very similar to the Series 5 lead, but it's coated, as you can see, and so clearly, if you were to chip some of that coating off and have some raw lead exposed, you would be able to see that. So that's one of the benefits of the Series 6. Another benefit to the Series 6 is that it has removable sample stacks, so that if you wanted to load your stacks somewhere other than on the unit itself, you could do that. Or I was actually at a facility last week where they were not using the restack feature. They were basically loading on one side and unloading on the other. And this would lend itself very nicely to doing that, as you could just continue to add stacks to the right-hand side. When you purchase one of these systems, we always include one pair of stacks, either it's 100 or a 50. And we use what's called a lock and load mechanism, where you don't, we had done something similar, not from a removable stack standpoint, but from what we called a carrier cassette a few years ago, 20 years ago, where you would take this carrier cassette and you would put it on top of the stack, and you could basically load samples into your existing mass. The problem with that is that when you did that, you had a little panel that you had to lift and lower to be able to put the samples in place. But in the case of the Series 6, that's not the case, because it automatically retains the sample. So I'm gonna switch gears just a little bit here, and I'm going to show you the actual unit. And remember, this is a live demo, so anything can go wrong. So let's see. Okay, so here we have the Series 6. Okay, and I'm going to turn it toward the camera a little bit here. Okay, so this is the Series 6. These are the 50 sample stacks that we have on here. Okay, and so I want to change out this stack. So basically, I'm going to unscrew. There's a little plunger that I need to pull out. That on the production units, this plunger's in the front, by the way. Notice it turns, and it automatically retains my samples. So here's my samples, are automatically retained. You can take that, you can place that on a table somewhere. You can load, unload. If you have multiple of these, you can take it, you can load it back on the unit. So to put that back in place, basically we just come here, lock and load, load and lock, and we put it back in place. Okay? All right, so let's go back to our presentation now. Thank you. This is my assistant, Hope, and she's doing a great job. So we also have the integrated touch screen. So we say it's a tablet-sized integrated touch screen, so it's a 7-inch diagonal. So what does it do for us? Number one, it gives us count info, so that when we're doing an analysis, we can just come up very easily and see what the system is doing, see if it's in a count or not in a count. From the front panel, based on the icon, so we have the check icon, which means it's passed all of its self-diagnostics. It could also show us a low gas condition or a no gas condition or no gas flow, which typically means that something has happened to the detector window or something else. So there's a caution and a warning, right? So basically different color icons with the exclamation point showing you if there's problems. Also could be if there's voltage parameter issues. So you have your 12-volt power supply is not up to snuff. It also allows you to do setup options, and these are setup things that are related to the hardware itself, like do you want it to beep or not beep when it's doing certain things. And then the big thing that this allows for you to do is the express option. Again, you can start counts in Apex Alpha Beta just like you do on your Series 5, just like you do on your LB4200, but on the Series 6, you can start counts directly from the front panel, and it's just like starting counts in the software itself. And those would be express batches or daily QC batches. All right, so let's talk about where we've improved the gas conservation. So back years ago, we came up with the concept of gas conservation that we used in the Series 5 XLB. And what that did for us is that it took a typical gas usage from about 6 tanks a year or a tank every 2 months, down to a Series 5 XLB where the gas lasts for about 9 months or so. And again, depending on your usage and such. We are expecting that on a Series 6 LB that the gas usage should go down to about 1 tank every 2 years or so. And so and how we do that is through several mechanisms, but one of the ways that we're doing that is through the use of the non-gas flow guard detector. So up here on our slide, we see that on the detector we have gas flow in. We have so much gas that's flowing through the detector, but some of the gas actually is diffused through the window, as you can see here, and then that gas exits the sample detector and goes into the guard detector. Once it's in the guard detector, it has to fill that it's a much larger volume than the sample detector. So to get good efficiencies, to get good response from the sample detector, it only takes just a few minutes of purging the detector for that to happen. The guard detector, however, it can take hours up to, say, 12, 14, 16 hours before the guard detector is fully purged. That's one of the reasons that we continue to do this very low flow when we're in standby mode. The Series 6, rather than having a guard detector out here, there's a gasless guard detector. So that's not in the gas flow circuit. So on the back side of the Series 6 detector, we have a gas flow sensor, and then allows you to vent or capture. So just natively, without doing any kind of conservation at all, we're using about a third the gas in the Series 6 as you would use in the Series 5 XLB, and markedly less gas than what you would use in an old LB5100. Also the panel, if we had a gas interruption, in other words, that our gas input pressure was wrong, so below 8 or above 12 psi, then you would have a yellow icon come up. Whereas if your window is compromised, you'd have a red icon come up. Maybe instead of a red icon, maybe we should put a green dollar sign there, because that means you're going to be spending a lot of money to replace your window. So here we have the new kind of guard detector. This is the first, as far as we know, this is the first time that we have used a non-gas flow guard detector in a gas flow system. It's a plastic scintillation detector. It's more efficient than the gas flow detector that we had used in the past, and it's more rugged than the gas flow detector we'd used in the past, whereas the original Guard detector uses an anode wire that is about half the width of a hair, of a human hair. And what happens is if you have, over time, is that can break, and that causes all sorts of problems with your system. Now, this isn't the first time that we've done a plastic scintillation Guard detector. We've done those on the iMatic and the iSolo for a number of years now, for more than a decade. But the difference in this plastic scintillation Guard detector is that it uses the silicon photomultiplier as opposed to a photomultiplier tube. Because if we had continued to use a PMT as opposed to a SIPM, what happens is some of that trade-off that you get from not having an anode wire and such, and from a reliability standpoint, would have gone away. So on the SIPM, it is less temperature dependent. It's more rugged than a photomultiplier tube, and it's much smaller. So that makes the detector area smaller, which means less shielding is required to cover it. So this is, again, we took what we had done on the iSolo and the iMatic, and we basically improved it, and so that's what we have now. And it also opens future possibilities. So we've taken the output of this Guard detector and we fed it into an MCA, and we see things that we could have never seen before, whereas the resolution of a flow detector is so poor, you can't really tell one thing from another, what the source of your background is. Where with this, we can actually tell some things. And basically what happens from all of this is you could change your gas bottle, go from no gas to good backgrounds within just a few minutes, rather than having to wait till the next day to start doing background counts. Okay, another change that we've made on the unit is in the area of sample identification. So as a nod to backward compatibility, we continue to use, you can see, the old style binary coded decimal, get all the way there. So you notice you've got a couple of holes here. This is just a way to identify each sample as it's counted. Okay. But and we still support these. We still use basically the same carriers that are used on the iMatic and the LB5100 and the Series 5 XLB. But we're now doing that with very modern hardware, whereas before we had these, seemed like they were LEDs and transistors that came from the 1960s or 70s that we were using before, and now it's all up-to-date surface mount, very nicely done. But in addition to the binary coded decimal, we are doing a NFC RFID tagging, which allows you to actually tag your sample. We currently don't have any kind of an application to do this, but it's the type of thing you can download the application onto your Samsung phone, to your Android phone, and you can actually write to these tags. You can buy the tags off of Amazon. You take these tags and you affix those to your sample. I can see at some point in the future air filters having these embedded in the filter cards, whereas today you buy air filters that have the barcodes on there. I can see people putting these NFC tags in there, and not only would it have the identification information on there, but you could also put more information. You could put GPS location. You could put the filter on and off flow, filter on and off time. All that information could actually be embedded in the sample, so that you don't count sample A and think you're counting sample B. And then another thing that we've done, and we'll show this again as we get back onto the unit in a few minutes, where you can access the slide from the front of the unit through the new sample access dust cover. So very simple to get to, and it also should be much safer for people to use. So less chance of getting your lanyard stuck in the sample changer this way. So the system comes very well equipped as is out of the box. Again, the major options are you either do a 50 or a 100 sample option. but the system already comes with a keyboard tray. It already comes with an articulating monitor arm. But one thing that is optional is the barcode reader. And this barcode reader is not just reading the traditional barcodes, but it will allow you to read the 2D barcodes, the QR type codes like they're using by the FedEx and UPS guys. Lots of potential to do a lot of things with that, with this barcode reader. But in addition to all that, it's a camera. The barcode reader is a camera. So you can go back and you can review and make sure that you counted what you thought you counted. You can make sure that what came out of the sample slide is the same thing that went in, and I'll actually show you some of that in just a few minutes. Also through the front panel is we have health tracking. So you go to the health tracking screen, and basically there's self-diagnostics built into this. So over here we have all of the results of all these tests. We have basically the front portion, or the detector portion, and then we have the outside portion. So some of the things that we do, of course, are voltages, obviously, but we also measure the detector temperature, and we measure the ambient temperature. Okay, we measure the gas pressure. So we know that it needs to be, like I said, between 8 and 12 psi, so what, 0.5 to 0.9 bar, and then what the outlet flow rate is. If any of these parameters are out of tolerance, they will turn red. So it'll be obvious what the problem is, or at least where the problem is. Something else that we do is that we measure the humidity and the pressure. What are we doing with that information? Well, right now we're just saving that information. At some point, though, we may be able to make some correlations that say that if the pressure changes so much, then maybe we need to do some recalibration, or maybe we can do some predictive corrections. And you know, based on the barometric pressure changing over time, maybe we can predict when you're going to have a high radon time. You know, lots of potential for this. But you know, step one, let's collect the information and take a look at it and see what correlations exist. And then in the future, and starting now, is Canberra has a new technology that we call Lab Pulse State of Health technology. And basically what that is on germanium detectors and some other products. Basically they're taking the health information of the unit, of the device, and they're putting that out on the cloud, and they're basically watching for things. And so they're doing predictive maintenance. Okay, so we know that this detector is going to need servicing on such and such date. And so we're going to be integrating that into the alpha beta world also. So how do we actually do counting on the unit? So we have the traditional way, just like you would do on a Series 5, where you can go to the standard Apex alpha beta interface and you can start a count, right? So you can, if you pre-create a batch, you have a batch of samples, you can take that batch, you can drag and drop it onto your group plate, just as is done here. Or we have the ability to do an express count. So if you have a procedure that's set up and it has all the correct parameters in there, basically all you have to do is choose a group plate and hit the count button. It will do exactly what it did the last time that you hit the count button. If you needed to change that, instead of hitting the left 2/3 of the count button, you'd hit the right third, and you can edit what that is going to be counting. And then the other way, the new way that you can do the counting. So those last two slides basically were what happened on a Series 5, right? On the Series 6, though, let me run this slide again. So you can do express batches, or you can do QC counts. So that's equivalent to basically what I was just showing you, except you come up to the touch panel. And what do we know when we see this? Well, first off, we see that we have a check mark, so that means that all of our things are within tolerance. We know that it's not counting because this is grayed out. This is like an emergency stop button or an abort button. We know that it's currently not counting because this is 123 slash as opposed to green 123, which you'll just see in just a second. If I'm ready to start a count, I hit the start button. Currently, since it's not counting, my high voltage is turned off. My gas supply is good, and then I have the ability to go into status. So just a demonstration here. Hit it, choose what you wanted it to be, and then it goes off and it starts counting. So I'm actually going to take a break from this now, and let's go back to our monitor, and let's see if we can do this. Again, live demonstration. Anything, you just never know what's going to go wrong. Confidence, yeah, it's got to have confidence, he says. So we know something's going to go wrong. No, that's not true. So this is the actual front panel of the unit, okay? So Series 6, System 3, the last procedure that was run on here was a procedure that was called QCC. Okay. Does that help? Makes it worse. Okay, turn it back up. Okay, we'll just do the best we can with this then. Pull the unit up a little bit. And zoom out just a bit. Okay, so this is the front panel. To do a count on the unit, basically what I would need to do is I would come in, I would hit the start button, okay, and then it tells me what procedures are available. Again, there are certain procedures that have set up a certain way, and if they're set up a certain way, then you can use them for an express count. All right. So as you can see, this is a unit that we've been testing. So the name of this procedure is incredibly short, right? This is a really long procedure name to check to see how it fits. Okay, and that's going to Group A. So that's not the procedure that I want to count. I want to count unknown AB Series 6. Okay, so say unknown AB Series 6, and that's Group E. So I'm ready to count. I hit the count button. Request successfully processed. It starts moving. Notice that the flashing hand here. So warning not to interfere with the unit. We know that the high voltage is turned on. We can see that here because it doesn't have the slash anymore. Our gas is still good, and we're not yet counting because we haven't slid into the chamber yet. So it's still looking for Group E. Okay, sliding in. Okay, so from here I can exit back to the main menu. Okay, or from here I can also notice this is 1, 2, 3 now, so that means it's counting. I can click on 1, 2, 3, and it actually takes me to the screen showing the count that's in progress. So what's the what group? It's Group E, and it's carrier number 3. And what's the batch name? Really long batch name. Gross counts, guard counts. How much time is remaining on this count? Are there any additional groups that are queued? And what is my sample ID? Okay. Also, as it's counting, it is, as I said, this one does have the barcode reader on it. So it is, these aren't barcodes, but they're just regular samples. And I will warn you before I show you this, the picture is not the final quality picture that we're going to have, because there's some setup that needs to be done. So, so I come in here, and it actually shows me the picture of the sample. Okay, that was counted, or that is being currently counted. So counting is stopped. Okay, So the next sample, but again, we can go back out here to the main menu. Again, it's going to count. I think that's my last sample in this batch. And notice here, so gas conservation, so this is green. I'm not sure if that comes through, but if this is green, anytime I get any sample counts, this would turn yellow. As long as it's counting, it's green, so there was just a count. The Guard Detector is green when it's counting, and then yellow anytime you get a flash. Here's where the speaker is, so that if you have the sound turned on, you'll be able to hear sample warnings and such. So, so that sample that counted, no picture because it's just pulled out. All right, so back to the main menu, and it's restacking again. So let's talk about, since we're here, since I already have this set up, let's go ahead and talk about what some of these other things are. So if I go to the Setup or Settings button, then in here, notice it's still showing me what's happening on the sample changer beneath. So flash, 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 restack, flash, flash, flash. Once I'm in here, I can go to the sample changer advance, forward, in, out screen. On this screen, it allows us to do move sample changers in and out and such. This is to clear jams and such. Basically, this was the only control that you had on the Series 5 front panel, on the Series 5 XLB and the Series 5 LB5500, is you could clear jams with the front, but you couldn't start any counts or anything. So, so anyway, basically the same functionality here. Okay, so let's exit back to the previous menu, and then we have the health screen. Basically shows me all my health parameters. So everything's green, everything looks good. And then back out, and then into the setup screen. So we have different settings here. So we have muting all of our changer warnings. We have the sample done warning, gas low warning. We can adjust the screen brightness. We can adjust the audio volume, whatever we need to do. And then we have a screensaver for this screen. So right now it's set up for 60 minutes. So basically after 60 minutes it gets a very, very dim. To wake the screen back up, you come in, you touch it, and it starts back up, back to the main menu. All right, so I want to point this out to you again, so I need you to pay attention to what I'm about to do here, because this is going to be the point of my poll. All right, so I want to start a count, okay, and I want to start not a procedure, but I want to start my daily QC. But that doesn't matter. I just need to start something. So I hit count, right? Now notice what happened. It went back to the express count screen, right, to allow me to start another group if I want to. Is that the right behavior, or would it be better if it went back to the main menu, or would it be better if it went to the count screen? Which of those is the right place for it to go, or are any of those the right places to go? So I'm going to send you the poll now, and that's going to be open for a couple of minutes. So if you guys can respond on that, that would be great. So choices are A, it comes back to this screen to allow you to start again. B is to go back to the main menu, and C is to go to the count screen. Actually, I might have B and C backwards. I've got B and C backwards. And then D is maybe it should do something else. Maybe there should be a song and dance. I don't know. So if you guys could help me with that, because that's an internal debate that we've been having. This unit is on the verge of being released, and so we're finishing up a few, tidying up a few loose ends, and that's one of the loose ends that we're trying to work out to make sure that we're doing it the way that you guys would want it to be done. As I said earlier, this is this is a work in progress, and there's the possibility for built-in upgrades as we go along. and as such, it gives us the ability to make changes on the fly and improve things as we go. Think something that rhymes with my phone about improving things over time. Okay, so I have to turn my camera back on. Oh, you can see me. Excellent. All right, so here's the Series 6 in Apex Alpha Beta. We haven't talked a whole lot about Apex Alpha Beta, but notice that we have a new icon here. So this is the old Series 5 icon. This is the Series 6 icon. Notice on this particular unit, I've been running multiple units. I've been running the this is my System 3. I was also running System 2, but that's still down in the test area right now. I was also running a Series 5 on the unit, and the LB4100 and more LB4100s. So lots of stuff can be run on here at the same time. But the point I wanted to show you, so we come in here to data review, and we look at the counts that we've done, and I say, okay, so what counts did we do? And so here I did 3 counts. So here's all 3 counts individually, carriers 3, 4, and 5. But if I come down here to the first of these, and then I come down to picture, notice that it shows me the before picture and the after picture. So if you had a smear paper in here, you would just look at the after picture and say, oh, so I had something going in, but I didn't have anything coming back out, so that means I lost my sample. Or you did your daily check and you realized that your source check, your alpha, was really, really low, as in nothing. So you go back and you look and you say, oh, I forgot to put my alpha source in. Oh, or I put it in the wrong carrier. Or, oh, I put it in upside down. So you can use this picture feature to be able to see all of those possibilities. All right, so that takes us to the options that we have available, and so we have the model, the Series S6, Series 6 LB 2050 is a 50 sample. The Series 6 LB 2100 is the same, except it's got 100 samples. It has, both of those come standard with a cart, with a monitor arm, with a keyboard tray. They come standard with the RFID reader, with the BCD carriers. So the 50 sample has 50, the 100 sample has how many? 100, thank you. All right, so what are the options over and above that? So we have the installation as an option. So in the past, the Series 5, if you bought a domestic Series 5, the installation was part of the package. In this case, you probably still want to put that on there, but we're giving the option of self-install. But it's highly recommended, and in fact, if you do get the installation package, then that makes it an on-site warranty versus a return-to-factory warranty. One of the things about the unit, though, that we didn't really mention when I had the system pulled out was that being that it's a sample or a system on a slide, so where the system slides away from the lead shield, when you pull that out from the lead shield, you can actually detach that, and that makes it a much smaller unit. So if you needed to ship that around and do other things with it, basically it's a self-contained unit at that point. So next optional, not optional, the required item would be the software. So S556C Apex Alpha Beta version. Let's say you have you're already running a Series 5 or an LB4200 and you already have Apex Alpha Beta. You simply would just need to buy an upgrade version if you were going to run it on the same PC. The next thing is the dual stage regulator. You probably already have one of these, although you would want to double check because you wouldn't want somebody to come on site and expect you to have a regulator and not, because they're not expensive, but it's expensive if you get somebody on site and they don't have one and you have to acquire one. A lot of most Series 5 XLBs out there have a single stage gas regulator. You can use a dual stage wherever a single stage is used, but the opposite's not true, so just make sure that you have a dual stage. We have a computer that's available with the system. That's, of course, everybody's running Windows 10 now. We're not doing anything Windows 7 or Windows XP or any of those old Vista or any of those things. So it's standard Windows 10 software. And then we have a spec sheet that has lots of options for you to go through, and mostly they're related to sample carriers. Do you want barcoded carriers, and do you want those for PAS samples or SAS samples or SMS samples, or whatever type of samples that you're needing it for. Okay, so was there anything else that we wanted to talk about here? I think that's the main thing. So what I'll do now is we'll go ahead and open up the floor to some questions. And I've already got a couple of questions here, so I'll start with those, and you guys can come up with your ask your questions as I'm going through these. So the first question that I have is that does the Series 6 have its own memory to keep the information such as the daily background and QC? And the answer to that is no, it doesn't do that. The person who asked this question is coming from an iSolo, iMatic standpoint, and the unit, basically, when it saves the data, it saves it to the Apex Alpha Beta, which saves it into a SQL Server database. And once it's into the SQL Server database, it's available to do lots and lots of different things. So you can use our Apex Alpha Beta software. You can chart your data that way. You could use Excel to pull your data in through a SQL Server through a query and link it that way and do your own charting. Or there's third-party packages out there that allow you to basically pull data in and do quality control on. Next question was how many different diameters of samples can be measured? Up to approximately 60 millimeter sample. Anything below that, up to about 5/16 of an inch deep on the unit. Maybe just a little bit deeper than that. It really depends on the makeup of the sample. Third question. Let's see. If the connection between the printer fails, does that cause a problem for the QC? And that kind of goes back to the first question. And no, the data is again, it's regardless of whether you're starting the unit, the count on the unit itself, or you're counting the unit through the software, it's going to, either way, it's going to be saving the data into the software, the QC data. There's two steps to it, basically. There's the QC side, where you're actually doing those daily checks, those daily counts, and then there's the charting and reporting side, which is done kind of after the fact. I want to show you one more thing here on the unit that I just realized that I didn't show you. So just bear with me just a second. Okay, so we have the unit again that I meant to do it. I just forgot when we had the unit when we were working on it. Move my things around here a little bit. So I'm going to pull the I'm going to pull the latch. Okay, then I'm going to actually pull this out to show you some of these components. Okay, so notice how nice and far that this falls out. So as I alluded to a few minutes ago, this entire part will disconnect from the unit itself, so that if you did need to maybe ship this back to Canberra to be worked on or whatever. It wouldn't be. It's not like you're shipping back 800 pounds of lead. That would be in here. So here we have the Guard Detector. Okay, and within this chamber, basically, you can lift the Guard Detector up, and we can see what we have our sample detector here. And connected to the sample detector is what we call the front end board, which is the preamplifier, the high voltage, all of those different things. So very easy to see that. The detector chamber is here, right? So very easily, if you take tweezers or whatever, you can access this area to pull anything out that is stuck in there and such. And if you needed to go further than that, there's 3 screws here, right? So basically, you take those 3 screws out, and basically you remove that, and you're able to move forward and actually remove the detector from the unit. The detector is attached. There are 2 screws here. There's normally 2 screws into the preamp that holds this all together, sandwiches it all together, and very compact package here. Okay, so again, very easy, slides into the lid shield very easily, and very compact design there. Okay, so do we have any additional questions here? Let's see. So somebody has asked a question, going back to the unit memory question, the unit needs a constant or live connection to Apex CPU for procedural information and seeing the count data. If it needs a live connection when the sample changer is doing its thing, but to start a count, you need a live connection. So for example, if I were to go in and close Apex Alpha Beta, and I think it continues to run. Yeah, so it continues to run here. So with Apex Alpha Beta closed, but if I close the service also, I'm not sure you guys can see that very well. Let me zoom in just a little bit for you. Yes, please. Yeah. But okay, so if I zoom in on that, so notice I can still start a count even with Apex Alpha Beta closed. However, if I close the service over here in the software, I think what's going to happen is it's going to come up and tell me that I can't start a count. But I'm not seeing that happening now. Oh yeah, there it is. It says no connection to Apex Alpha Beta. So if you were in that condition, it would let you know that you were in that condition. Okay, so another question is what gas would be used on the unit? This has been designed for P10 gas. P10 is typically what everybody uses, and there are some people around who started using a CO2 argon mixture, which seems to have about the same properties as P10 gas, so that seems to work nicely. If you're in an environment where you want to use pure methane, that probably will not work because this unit is not designed to go up above the 1500 volts or 1600 volts or 2000 volts that would be required for working in simultaneous operation with methane. Are there any additional questions? No questions. Wow, I must have done it perfectly, or I put everybody to sleep, one or the other. Let's see. Okay, so I have a question. How similar is the database of Apex to the old Eclipse. So we will probably do a webinar on Apex Alpha Beta fairly soon, where we can talk about some of the differences in Eclipse and Apex Alpha Beta. But basically, what you need to know is Eclipse used an Access 97 database, the .mdb database, that is not even supported by Microsoft anymore. You cannot, you have to use a third-party package to be able to convert that MDB file over into the new format of Access today. So structurally, the two databases kind of do look similar. There's a batch table in the Apex Alpha Beta database, and there's a batch table in the Eclipse table, and then there's a sample table in a sample aliquots table in Eclipse, and a sample table in Apex. So very similar naming. Sometimes it's named exactly the same, but being that in Apex it's a SQL Server database, it is much more powerful. You don't have the speed limitations or the memory limitations or the size limitations that you have in Access. Even if it wasn't an Access database that was so incredibly old. So it's and one of the other things that's related to that is in Apex we're using STML reports as opposed to crystal reports, but so you're trading one third-party package for another third-party package. But the nice thing about how it's been implemented in Apex is it's actually embedded in the software, so the editing of the reports and such is done through the Apex interface. So it's very very convenient because you don't have to keep up with some third parties' different versions. That you always have the right version that you needed. The next question was, can you remove the counted stack the same way that the load stack is done? Yes. I actually mentioned it in one of the slides, I think, maybe, in that the stacks are interchangeable. On this particular unit, they're not interchangeable because there's a plunger that's on it, and on one it's on the front and the other it's on the back. But on the production units, the plungers are always on the front, so it's very easy to get to. But yes, it would be the same mechanism for the alpha beta for receive stack. For the send stack is exactly the same. You can just move from left to right and have no worries. These particular ones are my prototypes, and so this just is a bare aluminum. The actual ones have a coating more like what the masts have, so it slides much better and such. Also, keep an eye. I have some other ideas of things that we're going to do on these in the future. That some more options, and anytime somebody comes out with something innovative like this, there's probably going to be some third-party options out there too if people want to add things on and such. So be thinking about that too. But lots of different ways to do this. So good question. All right. So any additional questions? Okay, well, great. Well, I guess we can wrap it up. We're at about time anyway. So I do appreciate everybody's attention today and for coming out to spend an hour of your time to listen to me talk about this system. I'm very proud of it. I think it's really going to be successful, and it's the first of many great things to come from Mirion Canberra in the coming months and years. I also want to mention that we have another webinar coming up. The next in the series is in November 14th, and it's going to be on low background gamma counting, and that's going to be with Dr. Will Mueller. He's one of our physicists here in Mirion, and he's going to give a really good overview of that material. So be on the lookout at our website, which is canberra.com/webinars. And also maybe on the front page splash, and if you signed up for this, maybe you'll get an email from Hope inviting you to that one also. So anything anything you need, hopefully you've got my contact information, and if not, you should be able to get it from the Canberra website. I appreciate your time and attention today, and I'll see you around. Thank you.